3.2, parallel lines cut by a transversal. So just like in video lesson 1, there's a lot of names and definitions that go along with parallel lines. So first things first, let's identify here that we've got parallel lines in this first example here. So here's my parallel lines. Again, two lines that are never going to intersect. No matter how far you draw them, they're never going to intersect. This third line here, this would be a transversal, and that's a line that intersects two parallel lines. So when we have that condition, we get different types of corresponding angles. So in this first one here, we've got this angle here, right, and over here, and we've got this angle as well, right? Those are called, in this first example, corresponding angles. So in this one here, two parallel lines are intersected by a transversal, then corresponding angles are equal in measure. So these two things. Again, the easiest way that I think to see this is if I was to basically make a box, right, around these four angles here, 1, 2, 3, 4, right? If I was to take that box and drag it over here, like so, what spot would match up with who? So as you see here in this box, this is the top right-hand corner would be this angle, and over here, top right-hand corner would be that angle. Those two angles correspond to each other. They're in the same location in both situations. They are equal to each other, right? Or they are congruent. All right, so you have here a couple things to notice. Again, just like video 1, here's the angle symbol. All right, and this one right here, this is called the parallel line symbol. So this one right here, that's the symbol for parallel. That's good to know if you don't know that. Again, just like before, we're going to talk about proofs and other things. The way we would describe this in a proof would be parallel lines cut by transversal form corresponding angles that are congruent. So here you go, corresponding angles that are congruent. This sentence here, you're going to see kind of throughout this next couple examples, the only thing that's changing is actually the specific angle type, but the rest of the sentence is going to basically stay the same. So let's look at this next one here, alternate interior angles. So again, if you've got two parallel lines, alternate interior angles exist if they are cut by a transversal. So in here, we've got these two angles here, this one here and this one here. So alternating meaning they're on opposite sides of the transversal, right? And interior angles means that they're between the two parallel lines. So here we go here. So the easiest way to kind of catch this is I've got this pair here. I've also got another pair over here, right? Those would also be a pair of alternate interior angles, right? We refer to sometimes this as like making a Z. So if I was to kind of trace a Z here, right, a Z-like shape, inside the little crooks of the Z, you've got this angle here and this angle here. Those would be your alternate interior angles. It also works the other way. It's just obviously it's like a backwards Z. So if I was to kind of do it this way, right, it would be that Z-like shape, kind of backwards. All right, again, here's the crook of that inside and the crook of that inside of that part of the Z, and therefore you know that those are alternate interior angles. Once again, this line looks almost identical to the other. The only thing different now is we've got this parallel line cut by a transversal form alternate interior angles, and they are congruent. So that's the only difference between those two sentences is the specific type of angle, because in both cases, the angle measures are still equal to each other. They're congruent. All right, next one, we've got alternate exterior angles, right? Again, alternate meaning opposite sides of the parallel, transversal, and exterior meaning outside of the parallel lines. So here's my transversal, right? That's a bad, let's make that a better looking line there. Just highlight it. There we go. So we've got that. We've got one angle here. We've got the other one here. Let's highlight that. And those are alternate exterior angles. Right? Again, they're outside of the parallel lines and on opposite sides of the transversal. So that sentence is going to look like this. And once again, power lines cut by transversal form alternate interior angles that are congruent. Once again, that little specific angle relation is the only difference in that sentence. So all three of those are very, very similar. The other one that is not similar to those is same side interior. So this one's different. Same side interior are supplementary, right? Supplementary. So what does that mean? Supplementary means that they, if you remember from earlier on from Unit 1, lesson 2.1, supplementary means they add to 180 degrees. So you notice here that these two angles, right? We've got this one and we've got this one, right? They are on the same side of the transversal. So here's my transversal. So if you notice, I kind of like to make this like little thing like this. This kind of shows you like both of those angles are inside. They're on the same side of the transversal. So and it's the same side, and they're both in between the angles. So they're not going to be equal to each other. In fact, the chances of them being equal is only if they were both 90 degrees. But I do know for a fact that they are going to add to be 180. So whatever this angle is, this first angle, and this second angle. So I'm just going to refer to it as angle 1 plus angle 2. We know no matter what, that would add to 180 degrees. Right? And if we were, describing this or writing this specifically in a proof, you're just going to say power lines cut by transversal form. Again, in this case, now we have a new phrase, a new statement, same side interior angles, and instead of being congruent, that's going to be supplementary. And that would be how we would kind of describe that. We've got one other thing. We could do a converse statement, meaning I can go backwards. So we could do this with any one of them. I'm just going to show it here with one of them, specifically the corresponding angles. So if I can prove that I have two pairs of corresponding angles from a transversal of two lines, I can prove that those two lines are in fact parallel to each other, right? And how we would describe that, very similar, is if two lines are cut by a transversal such that a pair of corresponding angles are equal in measure, or I could say congruent, then parallel lines exist. So again, it's just a backwards way of saying that, what we were saying earlier. So basically it's, let me highlight this for you. So it's like I have this line here. So if that's a transversal and these two things are equal, these two angles are equal, then the resulting lines that transversal intersected must be parallel to each other. Right? That's what the converse statement would be. Again, really helpful when we get into proofs, but we just kind of wanted to identify it here in this example. All right, next. Let's actually solve some of these things because this is kind of like where we would go. All right, now we could be asked to do this algebraically. So first thing, it's important to be able to identify. So I look here, right? I've got my parallel lines here. I see I got one here, and then I notice I've got a line that intersects both of them. So that makes that a transversal. So I kind of identify the two angles we're relating to each other, and I notice by looking at them, they're basically in the same location in each situation, right? So if I kind of think of it like I said, like the box around it, right? If I think about a box around either of them, this would be the top left-hand corner would be the 48, top left-hand corner would be the A. So those are corresponding angles. So once I know that they're corresponding, right? Corresponding, I'm just going to abbreviate here, corresponding angles, I now know that they would be equal, so therefore angle A is going to also equal 48 degrees. Over here on 2, again, I notice here I've got one line, two line, they are parallel. Now, how do I know they're parallel? All right, and before we knew they were parallel, we were being told based on the information, but here I don't know. How do I know that? I don't have anything. Oh, actually I do. These little tiny arrow marks that we have here that were there, I just kind of colored over them, but those are showing that these two angles, these two lines, I'm sorry, are parallel to each other. They're little symbols to show parallel. So I do have parallel lines, and I do have another line, a third line that is intersecting both of them. So therefore I have my transversal. So now I look and I say, okay, what do I got? I've got this angle here and this angle over here. So again, they are both on the same side of the transversal. and they are between. So that gives me same side interior angles. Okay, I abbreviated interior as INT. So now I know that B plus 48 has to equal 180 degrees. So if I go to solve this, right, I can simply just subtract the 48 from both sides. So B is going to equal 182 degrees. So I can answer the question by saying angle B is equal to 132 degrees. All right, example 3. Again, here's my little parallel line symbols that are on here. So I've got 1 and 2 parallel lines. I've got a third one intersecting. I look at my information. I've got this angle and this angle. All right, so they're on opposite sides of the parallel, and they're both between the parallel lines. So this is going to be alternate, I'm abbreviating, alternate interior angles, just abbreviating that statement. So therefore, they're going to be congruent to each other. So angle C is also 48 degrees. Last one over here, number 4. We've got, again, 2 parallel lines cut by a transversal. We're going to identify D and the 48 as the 2 angles I'm looking at and comparing. So once again, they are on opposite sides. This one's on the top side, this one's on the bottom of the green line, and they're both outside of the parallel line. So this would be considered inside, so therefore this and this are outside. So therefore, I know that they are alternate exterior angles, again abbreviating that. So therefore, they are also 48 degrees. All right, last 2 examples here we've got going on, and we're running out of time, so we might want to leave this to class. Actually, let's do that. I'm going to leave these 2 for class, and we'll talk about these tomorrow.